Okay, so before we talked about how we can prove triangles congruent. Now once we have triangles congruent, we can use their corresponding parts, and they will also be congruent as well. So what we're talking about today is something called corresponding parts of congruent triangles are congruent. So again, what that means is if you have congruent triangles, each of their corresponding parts would then be congruent. So taking a look at our proof on the first one here, we're trying to prove that J, so this angle J here, is congruent to N. Okay, and they gave me some information about L being the midpoint of a couple segments, and we'll talk about that. Essentially what I'm trying to do here is prove that these triangles are congruent, because if I get them congruent, then I can say their corresponding parts are congruent. Alright, so let's start with our givens here. They're telling me L is the midpoint of MK and JN. Now by definition, a midpoint divides a segment into two congruent segments. So I know KL is congruent to LM and JL is congruent to LM. I also see I have vertical angles here, so I can call those 1 and 2. Vertical angles are congruent. So it looks like I have these triangles congruent by side, angle, side, because the angle is included in between the two congruent sides. Now once I have triangles congruent, I can say then that their corresponding parts would be congruent, so J must then be congruent to N, because they're corresponding parts of congruent triangles. Okay, so it's kind of like just one additional step that we're talking about today. So let's write out our givens. Now the first thing I talked about were those segments being congruent. So let's write out that KL is congruent to LM and JL is congruent to LN. And that's because a midpoint divides a segment into two congruent segments. Right? Because they didn't tell me those sides were congruent. I inferred it from the fact that they told me that L was a midpoint. Next, I can say that angle 1 is congruent to angle 2, and that's because vertical angles are congruent. Okay, now I have everything so far to prove that the triangles are congruent. I have side, angle, side. So triangle, now be careful on how you say this. If I say triangle JLK, I have to make sure when I name the next triangle, the angles that are corresponding match up. So J corresponds with N in the other triangle. L corresponds with L. And then M is going to correspond with K. So again, J corresponds with N, L corresponds with L, and then lastly K corresponds with M if you look at that diagram. Okay, and that's because of side, angle, side. Okay, so then lastly here, we got to say that, well, if we have two triangles congruent, then angle J in the first triangle must be congruent to angle N. I wrote over some words here, so I apologize for that. And that's because corresponding parts of congruent triangles are congruent. Now we're done. Alright, next one here. I've got EA perpendicular to AD and FD perpendicular to AD, so I'll mark those in my picture. I've got AC, so this whole segment, congruent to DB, so this whole segment. Okay, and notice I'm using these curly brackets to show the whole segment, because what I don't want is for you guys to do something like this, because that's kind of ambiguous. Like, are you telling me AB is congruent to CD, or, you know, it's kind of confusing there. So I'm going to say, using these brackets here, that'll help me. Okay, so those are congruent, and then I've also got AE, so that's this part right here, congruent to FD or DF. There we go. And I'm trying to prove that this is true. So I'm trying to get that EC is congruent to FB. Okay, so these triangles are slightly overlapping. Okay, that's okay. If I highlight this here, I'm trying to prove that this green triangle is congruent to this pink triangle, because then I can say their corresponding parts are congruent. All right, so if I write up my proof, well, actually before I write my proof, let's come up with a plan, right? It looks like I have right angles here, and we know all right angles are congruent. I also have sides congruent. They gave me that, and they also gave me these. So I have side angle side. Actually, I'll erase this in the other triangle. Side angle side, that will prove the triangle is congruent. Okay, so givens. Okay, let's actually talk about the right angles first, because they gave me the other sides. Actually, that's where I really have to go first, is that I know that angle A and angle D are right angles. And that's because perpendicular lines create right angles. And what do I know about right angles? Well, I know that they're all congruent. Okay, so remember from day 2, we said that that has to occur together. Those are 2 steps there, because I'm talking about angle A and D being congruent. You can't say they're congruent without first talking about them being right angles. Okay, so they gave me the other 2 sides, right? So those are already in my proof. Side, side, here's the angles, so I have the triangles congruent. So triangle EAC is congruent to, now careful with your corresponding, F corresponds to E, D corresponds to A, and B corresponds to C in the other triangle. And again, this is by side angle side. Okay, so once I have congruent triangles, I can say their corresponding parts are congruent. So EC must then be congruent to FB. And that's because corresponding parts of congruent triangles are congruent. All right, so in this one, we've got KM bisects angle LKJ. So I know that these 2 angles, which I'll call 1 and 2, are congruent. I know that LK is congruent to JK. Oops. And I'm trying to prove that M is the midpoint of LJ. All right, so I'm trying to get this guy to be the midpoint, right? Now you got to think, what do we know about a midpoint? Well, a midpoint divides a segment into 2 congruent segments. So essentially what you're trying to prove here is that LM is congruent to MJ. Okay, and then if I get these congruent, then I can say that, oh, well, M then must be the midpoint. But in order to get those 2 parts congruent, let's prove these triangles are congruent, because then I can say their corresponding parts must then be congruent. Okay, so let's start there with the triangle idea. They gave me some information. Remember, I'm going to have to talk about the bisecting. Like, I know that 1 and 2 are congruent, but I got to talk about why. They also have this shared side that I'll use by reflexive property. So it looks like I have the triangles congruent by side, angle, side. So again, once I have the triangles proved by side, angle, side, I can say that these must be congruent, and then M must be the midpoint. So that's where I'm going. Okay, so let's talk first about angle 1 and angle 2, right? Make sure you don't forget to talk about that. And that's because, we know that's true because an angle bisector divides an angle into two congruent angles. Next, remember we gotta talk about this reflexive. Km is congruent to Km. Reflexive property. Okay, so far in my proof, I have the side they gave me, I got the angles, and I talked about the other side. So I have enough information now in my proof to say that these two triangles are congruent. So I'm going to say triangle KML is congruent to triangle KMJ, and that's by side, angle, side. Okay, so now that I have the triangles congruent, I'm going to say that their corresponding parts here, LM and MJ, must be congruent. Again, that's because corresponding parts of congruent triangles are congruent. Okay, so we're almost there, right? Because my proof line isn't telling me prove LM is congruent to MJ. It's saying prove that M is the midpoint. All right, well, if these two parts I've just talked about are congruent, then M must be the midpoint because it's in the middle of those two congruent segments. It's splitting that segment into two congruent segments. So at step 6, we're going to say M is the midpoint of LJ, and that's because, let me actually give myself some more room here. Okay, so I just shrunk up everything from before to give myself room. I can say M is the midpoint because if a point divides a segment into two congruent segments, it is a midpoint. Okay, so remember how the definition of midpoint is, a midpoint divides a segment into two congruent segments. This is just going the opposite way. Well, if I have a point that is dividing a segment into two congruent segments, well, then that must be the midpoint. And so that's the difference here at 6. So that's a new theorem that we've talked about. Okay, Km is perpendicular to LJ. Okay, so I know these are going to be right angles. And LM is congruent to JM. I want to prove that KLJ is isosceles. Alright guys, so if we're proving something's isosceles, that means we're going to need two congruent sides. Okay? Based on my givens here, you should be thinking, can I get these two triangles congruent? Because then I can use their corresponding parts like KL and KJ, get those congruent, then this whole big triangle here must be isosceles. So I'm going to see if I can prove LK congruent to KJ. So these are my ideas that I'm writing out. Well, based on what they gave me, I know that these are right angles, correct? So because of the perpendicularity. So let's call those 1 and 2. I know that those are going to be right angles, so they'll be congruent. I also see a shared side, KM. So by side, angle, side, these two triangles would be congruent. then these must be congruent because corresponding parts of congruent triangles are congruent. And then once I have those congruent, well, hey, that's two sides congruent. The triangle must be isosceles. So that's where we're going to go. All right, let's first talk about angles 1 and 2. I know that they're right angles. Remember, you're not going to jump to that they're congruent. You have to talk about them being right angles first, because all they told you is that those are perpendicular line segments. Okay, so we're going to say perpendicular lines create right angles. And then they must be congruent. So angle 1 is congruent to angle 2 because, well, all right angles are congruent. Okay, so again, this is a two-stepper. Next. Okay, so I talked about my angles. They gave me the sides, right? So that's nice. I still need to talk about this shared side, KM. And that's by reflexive. Okay, so that's my last side there. So now let's talk about the triangles being congruent. So KML is congruent to KMJ. And that's because of side angle side. And then, like I said, I was going with this. Now I'm going to say that KL and KJ must be congruent. Okay, because I've proved the triangles are congruent, I can now say their parts are congruent. Okay, now that I've got those sides congruent, okay, I have two sides congruent, I can just say that, well, triangle KLJ is isosceles. And that's because a triangle with two congruent sides is isosceles. Okay, squeeze that in there. Okay, and then you're done, right? Because by definition, a triangle is isosceles when it has two congruent sides. So that's my new little justification there that we're using in our proof. Okay, next, angle 2 is congruent to angle 4. A is congruent to D. And I know that AC is congruent to DF. Now I want to prove that angle B is equal to angle E. So I'm trying to get there. So that means that I should get these two triangles congruent, right? Now the problem is, right now I have angle 2 and 4 congruent, but they're on the exterior of the triangle. And that doesn't help me. I need to get it inside the triangle. Well, what you guys need to think about is that if these two angles are linear pairs, as well as these two angles, like let's give an example here. Let's say this is 100 and this is 100. Well, if they're both 100, their linear pairs would each have to be 80, right? That just makes sense, all right? So 1 and 3 then must also be congruent. So in proofs here, we're not going to use numbers as examples, though. We're going to use justifications. So I'll teach you how, in this proof, to talk about why then 1 and 3 must be congruent. And it's because supplements of congruent angles are congruent. So this is new, too. All right, so let's write out, oh, well, before we write our givens, right? Once I have 1 and 3 congruent, look at my pictures here. I have the triangles then congruent by angle, side, angle, angle, side, angle, and then I get B and E by corresponding parts. Now I'm ready. Okay, let's talk about that right off the bat. The first way we're going to prove that 1 is congruent to 3 is we first have to talk about 1 and 2 and 3 and 4 being supplementary. So I'm going to say angle 1 is supplementary to angle 2, and angle 3 is supplementary with angle 4. And we know that because these are what we call linear pairs. So linear pairs are supplementary, just like we talked about in Unit 2. Okay, we don't have to include the 180 because we're not talking about their measure here. We're just talking about the idea that they're supplementary, which means they would sum to 180. Okay, so next, keep in mind they gave you that 2 and 4 are congruent. So what we're going to say next then is that, well, then 1 and 3 must be congruent. And that's because supplements of congruent angles are congruent. Okay, and there you have it. So 1's congruent to 3. And that does indeed take 2 steps. So just be aware of that. Okay, so now they gave me the rest of it, right? Like these are the angles. They gave me another set of angles. And they gave me these angles, right? So I got angles, oh wait. That's not right. Here's an angle. Right, they gave me this angle. Okay, A and D are in the triangle. There we go. Because 2 and 4 weren't in the triangle, so we're not going to use that. Did I forget a given? Oh no, here it is. Here's my side. Alright, so angle, side, angle. Now it's all in my proof. So, I'm going to say triangle ABC is congruent to triangle DEF. And that's by angle, side, angle. Okay, and now I can say angle B is congruent to angle E, and that's because corresponding parts of congruent triangles are congruent. And you're done. Alrighty, so now we're going to prove a theorem. We know that the base angles of an isosceles triangle are congruent, right? We talked about that in Unit 1, I believe. We're going to prove that that's true. We're going to do it by using side angle side. Now they gave us a hint. We're going to construct an auxiliary line so that it's the angle bisector of angle A. So let's do that now. And let's call that intersection point D. Okay, so if that's the angle bisector of A, we'll label these 1 and 2. Okay, so if we're trying to prove that the angles are congruent, we're essentially proving that angle B and C are congruent, right? Well, I know 1 and 2 must be congruent because of how I drew that auxiliary line. They gave me that this is an isosceles triangle, so by definition here, AB and AC are congruent. I also have this shared side, the auxiliary line. So I can prove these two triangles are congruent by side, angle, side. Once I have their congruent, then their corresponding parts, B and C, must also be congruent. Okay, so let's start with our givens. And remember that when we draw an auxiliary line, we have to talk about it in our proof. So we're going to construct an auxiliary line such that it bisects angle A and intersects BC at D. Okay? And that's what we just did here. AD is our new auxiliary line. And we can justify this by saying an auxiliary line can be drawn. Alright, so since I created an angle bisector, I'm going to say that angle 1 is congruent to angle 2 because an angle bisector divides an angle into two congruent angles. And then what I can say is that AD must be congruent to itself by the reflexive property. Alright, so far on my proof, right, I have the side they gave me. I talked about these angles being congruent, and I have that shared side. So I have the triangles now congruent by side angle side. So triangle ADB is congruent to triangle ADC, making sure my corresponding angles match up here. And that's by side angle side. And now what I can do is say that angle B is congruent to angle C because corresponding parts of congruent triangles are congruent. And then we're done.